Topic Notes 6.1 Estuaries. So we're going to deal a lot with estuaries this year because we live right next to one. It's called the Lake Worth Lagoon. This picture is from one of my favorite places in our lagoon, and that is Munyon Island. It's a location we actually do a lot of field work in, so if you're part of the academy, you might find yourself there eventually. The other cool part about it is this is the site of a restoration project. Munyon Island has a bit of a history of being semi-developed, and all the mangroves and the channels that you're seeing there have been created through the restoration project, which in fact some of our Environmental Academy students back in the mid to late 90s worked on. So the big idea here is that estuaries are highly productive and dynamic habitats with changing physical and chemical characteristics that control the abundance and distribution of marine life. Of course, with that comes a whole set of learning goals here. Some simple, like defining an estuary and the various different types of coastal estuaries, to really getting into some of the physical and chemical characteristics and how they change throughout estuaries. We're also going to look at the productivity of estuaries, and of course that means primary productivity and even secondary productivity, which is actually really important in estuaries, and look at why estuaries are good nursery grounds. That whole productivity part leads into that, but we rely quite a lot on estuaries for young fish, juvenile fish, and even invertebrates to grow up. And of course, we're going to look a little bit at the history of the Lake Worth Lagoon, which is, of course, right here in Palm Beach County. So we'll start off with the basic definition of an estuary. And I will warn you that the definition of an estuary can be a little bit flexible. But basically, what it means is it's a partially enclosed waterway of some sort. They usually call it a partially enclosed embayment, where fresh and salt water freely mix. This does not include, of course, things like the Great Salt Lake or the Dead Sea. Even though they have high salinity values, they are enclosed completely. So there's several different types of estuaries, and I'm only going to really talk about three of them. The first is what we call a coastal plain estuary, and this is generally formed when water invades a low-lying area. Now, this particularly happened at the end of the last ice age, when sea levels started to come up. The Chesapeake Bay area is an example of that. Then there's the tectonic estuary. This is where tectonic activity will cause some sort of a subsidence or drop in the land area. And then, of course, seawater comes in and invades that area. An example of that would be San Francisco Bay. Then you have what we call a bar-built lagoon. And this is where sandbars build up parallel to a coastline. And generally, there's usually cuts within that sandbar that allow the ocean to come back behind it and exchange water with the lagoon that eventually starts to become influenced by fresh water sources coming off the land. And so there's where you get that mixture of the two. The Lake Worth Lagoon is sort of an example of that, although there's some kind of exceptions to it when we get into the history of the Lake Worth Lagoon. Estuaries tend to have a high biodiversity, and of course ecosystems across the planet that have high biodiversity tend to have a variety of various different habitats within a small area. This is very similar here. The Lake Worth Lagoon is a great example. We have seagrasses, we have mangrove forests, we have oyster reefs, we even have rock reefs, we have mud flats, we have sand flats. We have all of these variety of different habitats within the lagoon system, creating a lot of different opportunities for various different organisms to specialize and develop. Now we're going to start getting into the physical characteristics of estuaries. Now the first thing we're going to start with would be salinity. Salinity varies in an estuary depending on the sources and frequency of freshwater discharge from the land, and of course how open and flushing the salt water from the ocean is within the system. So salinity can vary greatly, from close to 0 parts per thousand all the way above 35 parts per thousand. Anytime you have a reduction of fresh water and an increase in evaporation, for example, you're going to have a higher salinity value. And we've read all of these types of values in the Lake Worth Lagoon over the years. Now I have a map here of South Florida, basically from Lake Okeechobee down, and you'll see all of the canal systems are kind of highlighted in blue lines. The reason why I point this out is that our local Lake Worth Lagoon is really governed by the amount of fresh water we discharge from our canal systems. Now, this is not a natural system, although there are natural inputs and discharges into our local lagoons, but by far we control most of that nowadays. Now, depending on the strength of the fresh water coming from the land, whether it's from a river, whether it's from a canal, whatever, will depend on the type of mixing that you end up having. So these are some classic examples of mixing patterns. There's first the saltwater wedge on the top right image there. Now this happens as the tide comes in from the ocean. It's going to push salt water inshore into the estuary. Generally, especially in the summer months, the water from the ocean is going to be higher salinity and a lower temperature, which means it's going to have a higher density. That means it's going to slide under the more fresh, warmer water in the estuary, creating a wedge underneath. This is especially prominent if you have a high freshwater flow coming off the land to kind of push over that saltwater wedge during high tides. Now, when the freshwater flow is much less and the saltwater is able to push in more, you'll have more mixing going on. And that's where you see on the bottom two where you have a little bit of wedge, but it's slightly mixed, and then you'll have total vertical mixing as you go up into the estuary towards the headwaters. Now we're just very briefly going over this because these patterns change even seasonally. So our second factor is temperature. And temperature will change dramatically throughout the course of the day and of course throughout the various seasons of the year. Because we're dealing with a shallower system, the sun's influences are going to have an effect a lot greater than you would in the open ocean. So think about it. If the sun's really bearing down, it's a really hot summer day, that water is going to get much warmer very quickly compared to offshore water. And same thing happens in the winter. If it's very cold outside in the atmosphere, that water is going to get much cooler a lot quicker than in the open ocean. Now, this also affects, of course, as we talked about before, the density of water. And so as densities change, you can actually end up getting vertical mixing because that surface water becomes cooler and more dense and will sink, and the warmer, deeper water will come up. This would obviously happen in winter months, especially in temperate regions, and it'll allow nutrients to actually come from deeper water. Our next factor is substrates, which when I say substrate, I'm basically meaning what's on the bottom. Generally, we'll have a mixture of things, either sand, silt, clay, and that all depends on the size of the particles we're talking about. Sand is generally going to be our larger particles in an estuary system, and then you get to silt and even clay, which is very, very small. Now, estuaries are known for having very soft substrate. This all has to do with deposition of particles. Think about it this way. If you have a very strong current, it's even going to carry some of the larger sediment pieces like sand and even some pebbles. If you have very calm currents, very, very slow currents, all of those larger particles are going to fall out of the water column and they're going to land on the bottom and start to gather as sediments. The finer particles, the silt and clay, will continue to be carried by those slow currents into various areas of the lagoon, where eventually it will get so slow that even those particles will drop out of solution and start to gather on the bottom, creating very muddy situations. Now, generally, this all coincides with a lot of organic matter that will tend to gather in these areas as well, which makes it a really rich, productive area. Now, sort of linked to all this is the concept of turbidity, which really has to do with clearness of the water, or cloudiness or haziness, if you will. And the picture on the bottom kind of shows you that. You have a beaker with very crystal clear water on the left side and very murky water on the right. Now, because of all the mixing, from ocean and from water sources on land, you tend to get very turbid areas within estuaries. Now, of course, high turbidity will affect the amount of light that penetrates and how deep that light penetrates in the water, which can affect seagrass growth, which we'll get to at another time. So oxygen is our last physical characteristic, and it's actually, of course, tied to biological processes as well. First, we do have a high potential of mixing within an estuary, which can cause lots of turbulence and lots of oxygen to be able to dissolve into the water from the atmosphere. And of course, temperature and salinity do affect the solubility of oxygen in water. So if you have high temperatures and high salinity, you generally will have lower oxygen levels. This obviously has a big impact on marine life. In the middle of the summer, if there hasn't been a lot of rain and there's a lot of evaporation, that water can get very hot and very salty. This is especially prominent if you go down to the Keys during low tide. And of course, another component of this is the muddy substrate. These muds tend to be very anoxic, especially as bacteria populations kind of break down organic material. So now let's talk a little bit about productivity. As I mentioned before, estuaries can be very productive, all depending on the conditions. Like we talked about before, having high productivity really means you have all the things that autotrophs need to grow. The autotrophs you have in estuaries include things like seagrasses, mangroves, algae, and if you go a little bit farther north, you'll have salt marsh grasses. And of course, in the water column, you'll have phytoplankton. When we see high productivity, we always look for nutrient sources. And in estuaries, nutrients can come off the land through natural and artificial outfalls from canals, runoff, things like that. But also it comes from the large amount of organic material produced by the autotrophs there. For example, seagrasses constantly produce new shoots, and those leaves eventually fall off and decay and become detritus. And that detritus becomes a very big part of the food chain and food web within the estuary system. As it turns out, primary productivity tends to be relatively low in the water column itself, although it's still going on, and that would be your phytoplankton. But your seagrasses and salt marsh plants make up the bulk of your primary productivity in an estuary. Having said that, very few marine species actually eat or feed directly on seagrass. Most animals can't digest it. So what's really happening is very much a buildup of dead organic matter. And that detritus forms a substrate rich in bacterial and algal growth. And that's really what's being consumed by suspension feeders and deposit feeders. They're eating the detritus, they're consuming it, but they're really digesting the bacteria and the microorganisms that live within the detritus. Another big factor within estuaries is that they really are nursery grounds for lots of young juvenile fish and invertebrates. And this is for a couple of reasons. First of all, you have high levels of nutrients and thus food available. You tend to have low levels of predators and lots of hiding places and shelter for these juveniles to live in. The picture to the left is actually of a young jack that we found seining out at Southern Bridge, which is not very far from our school. And again, an example of a juvenile species. And of course, this leads to our conversation about the value of the lagoon itself. Why are these estuaries so important? To start off with, we talked about the estuaries being a nursery ground. Well, that's really huge. The majority of commercially important seafood species that we deal with live at least part or their entire lives in the estuary. So they're all linked to that, including things like mullet and redfish and tarpon, snappers, groupers, things like that. Then, of course, you have tourism. Tourism brings in huge dollars to our local South Florida economy. Everybody likes to go out and go boating and kayaking and snorkeling and swimming and fishing. And this is all tied to our local estuaries as well as other coastal habitats like coral reefs. Now we're going to turn our talk to the Lake Worth Lagoon itself and get into a little bit of its history. The Lake Worth Lagoon as it is today stretches about 20 miles from the village of North Palm Beach all the way to about Ocean Ridge or the city of Boynton Beach in the south. Now, recently historically, the Lake Worth Lagoon was actually a freshwater body with plenty of freshwater marshes, and it was recharged from rainwater and groundwater that flowed from the west. Now, occasionally, storm surge would break through the island and create a saltwater intrusion within the lagoon, but then it would usually be sealed up by natural sand shifting along the beach and the shoreline. The only outflow from the lagoon was a swamp that became what we call the Lake Worth Creek that approached out towards the Loxahatchee River in Jupiter. You can see a drawing of this on the right. There are no pictures that I can find so far, at least. Of course, as more settlers came in, there was a desire for a stable inlet so that they could have a way to bring boats in from the ocean into a sheltered harbor. By the mid-1800s, there were reports of an outlet in the Lake Worth Lagoon, just north of where we now have the Lake Worth Inlet. It was eventually named Lang's Inlet after the individual who dug it, but it was unstable and required continuous digging to maintain, and eventually was covered over. A much more stable and, of course, the beginning of our current Lake Worth Inlet was dug in 1877. The pictures you see here are some of the earliest I've been able to find. The one on the right is from the 1920s, and you can see the Lake Worth Inlet right there in the center going back and forth. But if you look towards the north, you can see just how thin and unstable the island is. The picture on the left is from 1946, and it shows Annie's Dock at that time. Now, Annie's Dock extends off of the south side of the inlet. So what you're basically looking at is Palm Beach Island in 1946, which I think is kind of cool. So Lake Worth Lagoon has two inlets today. On the south side, we have what we call the South Lake Worth Inlet, or the Boynton Inlet, which is much smaller and more narrow. And then, of course, to the north, we have the Lake Worth Inlet. People like to call this the Palm Beach Inlet, of course, but it's the Lake Worth Inlet. And it's much wider. And of course, we do most of our port traffic and even some cruise ship terminals out of this particular inlet. So the bottom pictures show you some kind of historical shots. One of them that I think is really cool is the bottom picture of the Boynton Inlet. This is from the 1950s, and you can actually see kind of them working on dredging and cleaning it. And you look how shallow that is compared to what we see today. And if you've ever been there, it's a pretty deep channel. And of course, on the bottom right, you see Peanut Island circa 1976. Now, Peanut Island is what we call a spoil island, which means they took the dredging materials when they actually dug the inlet and they piled it up somewhere. Well, they happened to pile it right there and created Peanut Island. Now, for a long time, the island just sat there. They did put a Coast Guard station there, and of course, there was the JFK bomb shelter as well. But if you look at that picture, it's filled with Australian pines, which are basically a pioneer species. They're invasive exotic here in Florida, so they just kind of grew all over the island. Today, of course, if you go there, they've totally reinvented the island and created a lot of the more native natural habitats there. Through that process, they actually took a lot of the spoils and made more islands, including the Snook Islands along Lake Worth Golf Course, as well as several other estuary improvement projects. And even today, as they dredge the inlet, they do continue to dump sand on the middle of Peanut Island. Because of these two stable inlets, the Lake Worth Lagoon is a pretty salty body of water. The only fresh water it gets now is generally when we discharge from our local canals, or if we get a lot of rain and we have a lot of runoff from our local communities. This is a picture of the C51 Canal that enters out into the Lake Worth Lagoon. And remember, these are all tied to that big complex of channels that were developed by the Army Corps of Engineers to help drain the Everglades. And of course, what comes out of those canals has a big deal to do with the water quality in the Lake Worth Lagoon. So a few more historical pictures just for fun. The picture on the left is the Manalapan Island around 1930. And the picture on the right is actually, you can see Lake Worth Beach and the bridge there and the Lake Worth Golf Course, but there wasn't a date on this one, but I'm assuming it's probably after the one on the left. Now, some of you might ask, where did the name Lake Worth actually come from? Well, back when it was a freshwater lake, it was actually named in honor of William J. Worth, who was a military commander in the Second Seminole War. So these pictures are from the beach, but I still think they're kind of fun. The one on the left is from a pioneer family in the 1880s picnicking on Lake Worth Beach, or in the area of Palm Beach and Lake Worth. And on the right is a picture from Palm Beach itself in 1910. Kind of a different perspective of life. And look at that beach and look behind it. There's no condos. But of course, times they have changed, and the lagoon, as well as all of the estuaries along Florida's east and west coast, are under a lot of threats. You may have heard recently about the toxic algae blooms. This is a picture of the St. Lucie River with some of the discharges from the canals mixing with the estuary water there. It's high, those discharges from our canals are rich in nutrients, usually from some of the farmland. And that really ignites a lot of the algal growth, especially some of the cyanobacteria. But agricultural practices are only a part of the problem. All of the coastal development tends to input pollutants into the water. And a lot of the development, especially north of us towards Indian River County, they rely on a lot of septic systems. And that is feeding bacteria within the lagoons themselves. Now, we'll get into a little bit more of these issues within class throughout the year, but just wanting to put this out there because, of course, the health of these systems really reflects on how people perceive our local area and whether they want to spend tourist dollars here. So it's time to throw it back to you. And here's your question for today, a little contemplative one. In what way does the Lake Worth Lagoon, our local lagoon, affect your life? So think about that, write a little bit about it, and explain your thoughts. And until next time, keep thinking.